Hey guys, Kashyap here, and we're going to solve another LeetCode question. And today we're going to solve LeetCode question number 169, which is majority element. So, given an array nums of size n, return the majority element. The majority element is the element that appears more than n over 2 times, which is just more than half the time. You may assume that the majority element always exists in the array. So this just means that there's always an answer to our test cases, or inputs. So let's run through a bit of the test case and see how it's going to work out eventually. So nums is equal to 3, 2, 3, and our output is 3. So the way they did it over here is pretty simple. You could just divide the length of the whole thing by 2, and the length is 3 divided by 2 is 1.5. So we can just check for which element appears more than 1.5 times, or more than half the time. And so we can say 3 appears twice, 2 appears once, so the answer is 3. Same thing for the second one. The length of this is 7, and then 7 divided by 2 is 3.5, and then we can see that 2 appears 4 times, and 1 appears 3 times, so the answer is 2. So there's 2 ways to solve this, and one is way better than the other. So the first way is to just use the Python inbuilt function, and I'll show you how to do it. So first we can do our imports, but there is like a second way that is infinitely better. So here. So first we're going to do our imports so that we can actually use type definition in here. And what we're going to do now is we're just going to use the Python inbuilt function. So we have to iterate through the whole list. So we're going to do for I in nums, and we don't need zero indexing here because we don't need the indexes anywhere. So for I in nums, if nums.count of I, and this is an inbuilt function in Python that checks how many times an element appears in that array. So if nums.count of I is greater than len of nums divided by 2, which means that it appears more than twice, then we can just say return I. Now, this is good, but the count, nums.count, uses 2 for loops. So that gives us n squared time complexity. And even though this is good, you will see that it's a bit too slow in here. I'm going to show it to you right now. So it's already in judging phase, which means that it's way too slow for this code to even execute properly. Because over here, our constraints go all the way up to 5 times 10 to the power 4, which is way too big. So there's a second way using a hash or a dictionary. We're going to try that out. And we're just going to keep our import over here. And so here's how it's going to go. So first, we have to create our empty hash. So here's what we're going to do. So first, we're just going to iterate through the whole list. And then what we're going to do is we're going to create a dictionary, and we're going to save the occurrences of every single element in the dictionary. And because we're doing 2 separate for loops, not 2 nested for loops, we're going to get O of n space complexity and O of n time complexity. O of n space complexity because we have to save every single element in the list to our dictionary. So here's how it's going to go. First, we're just going to revert this. Okay, so first we have to create our empty dictionary. Here. Empty dictionary. So now we can create a dictionary. For empty dictionary, we're just going to call it dict, or you know what, dictionary to be more specific. So once we're done with our empty dictionary, we're just going to also we're going to loop through the array now. And then what we're going to do now is for I in nums, if I in dictionary, meaning that if it's already in the dictionary, we can just say, oh, sorry, I don't know what I'm doing there. I think you just do Control D. Okay, never mind. There, J. So what we can do now is we can just go through this array and check if it already exists in our dictionary. And if it does, we can just remove it. We can just increment it by 1. So if I in dictionary, what we're going to do is dictionary of I plus f equals to 1. Means we're just incrementing its value by 1. So we're looking for this key in our dictionary, and if it exists, we're just going to increment its value by 1. But if it doesn't exist, what we're going to do is dictionary of I is equal to 0. Meaning that if it doesn't exist, or actually equals to 1. So here's how it's going to go. So we're gonna iterate through our whole list, and if this element appears as a key in our dictionary, then we're just gonna increment its value by 1, meaning that each one of its occurrences goes up by 1 every time we see it. But if it doesn't exist in our dictionary, we're just gonna set its value to 1 because that's the first time we've seen it, so we set its value to 1. So once we're done with that, meaning once we're done with a completed dictionary, sorry. So once we create a dictionary with all our values in there, now instead of doing all this, you can just do counter, but I prefer this method because it's just a lot more descriptive and I can actually understand what's going on step by step. But later on, it is easier to use counter because it will save you a lot of time. You don't have to do all this. You can just use counter. So what we can do now is we can just loop through our whole dictionary now, which is again of n. So for I in dictionary, or we can just do for value, key value pair. For key in dictionary, if dictionary of key greater than len of nums divided by 2, return key. So what this does is just it basically checks if there's any element in the dictionary whose value is greater than len of num by 2, which is just it appears more than half the time. So we can try this out. We can check a few test cases. So sol is equal to solution, and we can do print of sol dot boom majority element. And then what we do now is we're just going to get our test cases over here. And let's try this out. Python 3 main.py 3. So yeah, 3, and let's test this out. So 2. So this actually works out perfectly the way we wanted to. So let's try this out, submit it. And we can see that this solution is a lot faster than before because we don't actually have to use the of n squared dot count method. And in the dot count method, it uses 2 for loops because it has to iterate through the whole array and check each instance of it. So now we have a pretty much optimized solution which has of n time complexity and of n space complexity. So remember to always use your hash maps instead of any other inbuilt functions, and happy leet coding.